Alright guys, here's the video about our Pythagorean theorem notes. So we start off by asking, who was Pythagoras? Pythagoras was an ancient Greek mathematician, philosopher, and cult leader. You can find out more information about him online. What is the Pythagorean theorem? Well, the Pythagorean theorem explains the relationship between the sides of a right triangle. In essence, it is the square of the legs, the sum of the square of the legs is equal to the square of the hypotenuse. We use the Pythagorean theorem to find the missing sides, a missing side of a right triangle. You can only use it to find one side at a time. The sides A and B are called the legs. These are the shorter sides, and they are adjacent to the right angle. Side C is going to be the hypotenuse. Hypotenuse is a long word. It is the longest side. It is across from the right angle. And which side you choose to be A and which side you choose to be B doesn't matter, as long as the hypotenuse is always C. One thing you should keep in mind is that for this formula, you should always use lowercase letters for sides. We use uppercase letters for corners, and that is actually extremely important. The formula that we are going to use for the Pythagorean theorem is going to be a squared plus b squared is equal to c squared, where again, A and B are the legs of the right triangle, and C is the hypotenuse. All right, so now we're going to apply the Pythagorean theorem to find the value of x in each of these problems. So the first thing you are going to do in every single problem is you are going to find your hypotenuse. It is across from the right angle. Once you find your hypotenuse, you are going to label it C, and then you're going to label the legs A and B. So we're going to make our list of givens. So A, we're going to use as 8. B is going to be 13. And C is going to be our unknown. Now again, it doesn't matter which one is A and which one is B, so long as the hypotenuse is C. But you'll notice that everyone tends to have a pattern that they use. I tend to just go left to right. So whichever side I get to first is usually A, and the other one is B. So in this case, I got to 8 first and then 13. All right, so after we write our formula, we are going to do our substitution. So we're going to have 8 squared plus 13 squared, and that is going to be equal to x squared. 8 squared is 64, and 13 squared is 169. So that's going to be equal to x squared. And 64 plus 169 is 233. And then what we're going to do is we are going to take the square root of both sides. So let's go ahead and say square root of 233. And it's 15.26. It tells us to round to the nearest tenth. And so we are going to say that x is approximately equal to 15.3. And in this instance, they didn't give us units, so therefore you don't have to give units back. Up next, we have a right triangle here. So again, the very first thing you're going to do is you're going to find your hypotenuse and label it C. And remember, the other two sides are A and B. Again, I tend to go left to right. Make your list of givens. So A, I'm using 7. For B, I'm using X, and C is going to be 9. With every problem, we make a list. We put in our formula. A squared plus B squared is equal to C squared. We do our substitution. So I'm going to plug in 7 for A. And then I'm going to plug in X for B. And for C, I'm going to plug in 9. 7 squared is 49. X squared is just X squared. And 9 squared is 81. I need to move that 49 to the other side of the equation, so I'm going to subtract it from both sides. And I'm going to get that X squared is going to be equal to 32. And you take the square root of both sides. And X is going to have an exact value here. So we know that X is going to be equal to 4 times the square root of 2. And the reason we know that is 32 is 16 times 2. And the square root of 16 is 4. But then we're going to go ahead and get the approximation as well. So we can see if we do the square root of 32, we get 5.65. So that's going to round to 5.67. And just to show you that the exact answer is the same, we get 5.656. So again, we're going to go ahead and round that to about 5.7. This next one is extra credit. So if you follow along, you are going to get a few bonus points on this assignment. So we have 2 right triangles here, and they want us to find X. What we're going to need to do here is find the A and B, or 2 legs, and add them together. Okay, so we're going to do the hypotenuse, the Pythagorean theorem twice. So on this first small triangle, we have our hypotenuse. I'm going to label that C. And my other 2 sides are A and B. Okay. Anyway. So for the first triangle, our givens are A is unknown. I'm just going to put, let's put X. And B is going to be 12. And C is going to be 14. Do our formula. A squared plus B squared is equal to C squared. All right, so A squared is going to be our unknown value plus B squared. And B is 12. Is going to be equal to C squared, and C was 14. All right, X squared is just X squared. 12 squared is 144. And that's going to be equal to 196. Subtract 144. And we get X squared is equal to 52. Let me check. It's 52. All right. And 52 is not a perfect square, so we will be approximating here. But we're going to take the square root. All right, and when we run that through a calculator, we get X is approximately 7.21. I'm going to round to 2 decimal places to start, and you round to 1 decimal place at the end. So I'm going to say 7.21. And then I need to find the other triangle. So now what I'm going to do is I'm going to relabel this triangle, but still A, B, and C. Since this one is already B, I'm going to leave it as B. This is my C1. So I'm going to do subscript. Let's call it C1. I guess C2. And then we're going to do A. That gives us new numbers. And B1 will be the same. All right, so now I'm going to make my list. So for A, I'm going to use X. And for B, I'm going to use 12 again. And for C, this time we are going to use 29. Same formula. I'm not going to write it again. But let's go ahead and do the substitution. So for A, again, we have X squared plus 12 squared is equal to And now in this case, 29 squared. Now you'll notice it's going to be very similar in the format. So we have x squared plus 144. And I'm be honest, I do not know off the top of my head what 29 squared is. 841. I should have known that, actually. We had that problem earlier on this same page. Or, no, it's later on the same page. That makes sense. All right, well, there we go. Minus 144. Again, I'm going to do that in here. And we get 697. And then we're going to go ahead and take the square root of 697. We get about 26.40. And because I'm rounding to the nearest hundredths here, that's why I'm adding the 0 there. So x is approximately 26.40. We're going to add these two numbers together. So, and we could do square root of 697 plus square root of 52. And we get 36.6 or 33.6. So the length here for this x is approximately 33.6. Box that in. All right, now we're going to do some application problems. We're going to draw a picture and determine the requested information. Now, again, the pictures do not have to be very good. I'm going to show you how simple mine are. A roofer leaned a 16-foot ladder against a house. If you see that anything is leaning against, or ramps are always the hypotenuse. In most cases, the ladder tells me it's a hypotenuse because in math problems, ladders always just lean up against things. So this is going to be my hypotenuse. All right. If the base of the ladder is 5 feet from the house, how high up the house does the ladder reach? So what I'm going to do is I'm going to select my triangle tool. If you hold down Shift, you get a right triangle. I am going to hope that the house is square to the ground. And then I'm going to label the picture accordingly. So for here they say it is a 16-foot ladder. It is resting 5 feet from the base of the house. And we are trying to figure out how high up this house it goes. All right, so our list of givens. We need to find our hypotenuse, which again is the ladder. We're going to label that C in blue. And the other two sides will be A and B. So A is X, B is 5, C is 16. Our formula again is going to be A squared plus B squared is equal to C squared. So that gives me X squared plus 5 squared is going to be equal to 16 squared. X squared again is just X squared. 5 squared is 25. And 16 squared is 256. We're going to subtract 25 from each side. And we are going to have that x squared is equal to 231. We're going to take the square root. And the reason I'm using the draw tool for that is it just shows that I added it later. And we're going to get that x is approximately equal to 15.2. Now, in this problem, we were given units, so units must be returned. 15.2 feet. Up next, Kurt is building a rectangular deck. If the dimensions of the deck are going to be 10 feet by 23 feet, and again, I'm just going to say this one looks smaller, so I'm going to make that one 10. And this one looks larger, so that one's my 23. Dimensions mean the length and width when we're talking about a rectangle. And they want to know what is the length of the diagonal. Diagonal is the line that connects the corner, to the opposite corner. Okay. And so we don't know what the length of the diagonal is. We're going to find the hypotenuse, and again, this is a rectangle, so that means this is a right angle. So we're going to find our hypotenuse and label it C. The other two sides are A and B. Make a list of givens. A is going to be 23, B is going to be 10, and C is our unknown value. Formula: A squared plus B squared is going to be equal to C squared. And then we have 23 squared plus 10 squared is going to be equal to C squared. 23 squared is 529. And 10 squared is 100. And that's going to be equal to, x squared. I didn't do my substitution on this one. I apologize for that. And then 529 plus 100 is 629. And then we're going to go ahead and take the square root of those numbers, or that number. And then we're going to get an approximation of 25.1 because it's 25.07. Remember, you look at the next digit, 5 or higher, round up. And again, that's going to be feet. Ashley jogged 3.4 miles east and then 5.7 miles south. As a reminder, we generally are going to consider north to be up, south to be down, east to be right, west to be left, just like the compass rose. Okay, so we know she's going 3.4 east, 5.7 south. So again, I'm going to draw a picture. And again, I'm just going to use my right triangle tool. So I'm going to start here. We're going to go this way. So she's going 3.4 miles east, and then she's going to go 5.7 miles south. And what we want to know is how far she is from her original location. And again, to do that, we're going to find her hypotenuse here, which is unknown. So again, find the hypotenuse, label it C. Other two sides are A and B. List your givens. A is going to be 3.4, B is going to be 5.7, and C is going to be X. Use our same formula. A squared plus B squared is equal to C squared. Okay, we're going to take that and we are going to run it through our calculator. We get 44.05. And then, of course, we take the square root. which gives us approximately 6.6. And that's going to be miles. All right, a 31-foot support wire is attached from the top of a 25-foot telephone pole to a point on the ground. How far from the base of the pole does the wire meet the ground? All right, so if you have a pole and you have something from the base of the pole, or you have something meeting from the base of a wall, whatever is going from the pole or the wall to the ground is usually the hypotenuse. So in this case, I'm going to use my line tool, and then I'm going to draw a pole, and here is the ground, and then we have a support wire connected to the ground. So we've got a support wire, a telephone pole, and the ground. Okay, again, we're going to assume this is a well-installed telephone pole, which means it's a right angle. It is a 25-foot telephone pole and a 31-foot wire. We do not know how far from the wall or the pole it is, so that's our unknown. As per usual, we're going to find our hypotenuse and label it C, with the other two sides being A and B. List our givens. A is going to be 25. B is going to be unknown. And C is going to be 31. Our formula A squared plus B squared is equal to C squared. We're going to do the substitution. So we have 25 squared plus x squared equals 31 squared. Now, I am not 100% certain I remember what 25 squared is, and I don't know off the top of my head what 31 squared is. So 25 squared is 625, and 31 squared is 961. Right? So that means 625 plus x squared is equal to 961. Subtract the 625 from both sides. And we get 336. So x squared is equal to 336, which we are going to take the square root. And that's going to give me that x is approximately 18.3. And again, it is feet. Now, anytime we teach you how to do something in math, we usually teach you how to go backwards as well. So now we can use this information to determine if three random numbers can be a triangle that is a right triangle. And we can also use this information to determine if it's an acute or an obtuse triangle. So first of all, I'm going to go ahead and type this out. All right, so for the Pythagorean theorem converse, we use the Pythagorean theorem. So if a squared plus b squared is equal to c squared, then the triangle is right. If a squared plus b squared is less than c squared, then the triangle is obtuse. If a squared plus b squared is greater than c squared, then the triangle is acute. You will always use the largest number as c when you're given three random numbers. So first of all, you do need to determine if the sides you are given could, in fact, form a triangle. Previously, we did discuss in the triangle inequality theorem that the sum of the two smaller sides must be greater than the third. So if that is true, we can then further classify the triangle as acute, right, or obtuse. So number one has 3, 7, and 9. First, we check 3 plus 7 equals 10, which is greater than 9. Yes, it is a triangle. I did a squared plus b squared is equal to 3 squared plus 7 squared. 9 plus 49 is 58 because 3 squared is 9, 7 squared is 49. C squared was 9 squared, and 9 squared is 81. 58 is less than 81, so it is obtuse based on our pattern that we have up here in the notes, right here. So I have a squared plus b squared is 58 on this side, less than c squared, which is 81, obtuse. Number 2 is 20, 21, and 29. 20 plus 21 is 41, which is greater than 29, so is a triangle. I did a squared plus b squared and got 841 because 20 squared is 400. 21 squared is 441. Add them together and you get 841. C squared is 29 squared, which is also 841. Since the two values are equal, this is a right triangle. Number 3, 4, 11, 16. 4 plus 11 is 15, which is less than 16, so this is not a triangle. And finally, number 4, 17, 17, 22. 17 plus 17 is 34, and that is greater than 22, so we do know this is a triangle. I can tell you right off the bat before I did any math that this is not a right triangle because isosceles right triangles do not have 3 whole numbers. Remember, an isosceles right triangle will be something times the square root of 2, if you remember from the video we watched the other day. But what's important here is that you test it out. A squared plus b squared. Well, a and b are both 17. 17 squared plus 17 squared is 578. And then c squared, 22 squared, is 484. 578 is greater than 484. So therefore, this is an acute triangle. Now, again, you might have noticed we do have our special right triangles on the next part. We will be covering this in further detail next week when we do trigonometry. But if you want to copy it down, you are free to do so. Until next time, stay safe. Bye.